Bismillahirrahmanirrahim. Okay, so let's get started. And today we are going to talk about the applications of Huygens principle. Uh, okay, so you know the statement of Huygens principle, according to which all points on a wavefront acts like new sources of secondary waves. Okay, so this means Huygens presented his own theory about light, and according to Huygens, a light is a wave. Okay, and remember, a wave is represented in terms of a wavefront. Okay, तो हाइगन्स के मुताबिक किसी वेव फ्रंट पर जितनी भी पॉइंट्स होंगे वो तमाम पॉइंट्स सेकेंडरी वेव्स के सोर्सेस की तरह एक्ट करेंगे। और अगर आपने टाइम टी के बाद किसी वेव फ्रंट की लोकेशन कैलकुलेट करनी हो तो हम क्या करेंगे, हम हाइगन्स के कंस्ट्रक्शन पर जाएंगे। सो फॉर एग्जांपल, सपोज this is some ray of light, so this is the propagation direction of light, and suppose this is a wavefront which is always perpendicular to the ray. So now we consider some points over here according to the Huygens geometrical construction, and these points are acting like sources of secondary waves. So let me draw a secondary wave produced by this point over here, produced by this one, and one over here produced by the first point. Now, according to the Huygens construction, the location of this wave front at some later time t will be the tangent surface which is tangent to all of these wavelets. So let me draw a tangent over here which is tangent to all of these secondary waves, and this tangent surface is the location of the new wavefront. Now we are going to prove the laws of reflection using Huygens principle. So you know the laws of reflection, that if light is hitting some reflecting surface, then the angle of incidence must be equal to the angle of reflection, and secondly, the incident ray, the reflected ray, and the normal at the point of incidence will all lie in the same plane. Okay, so look into this figure. In this figure, this horizontal line represents a mirror or some reflecting surface, and this is labeled as XY here. These are the incident rays which are coming like this. So AC, this is one of the incident ray, and it is hitting the reflecting surface at point C. Secondly, this is a second ray which is labeled as BD, and it will hit the surface at point Q over here. So if these are the incident rays coming like this, then you know the incident wavefront, this will be perpendicular to these rays. So this means the incident, if you want to describe this whole story in terms of wavefronts, so the incident wavefront is coming like this, and this incident ray first strikes the surface at point C, और बाकी जितने पॉइंट्स होंगे इस वेवफ्रंट पर वो सक्सेसिवली इन पॉइंट्स को टच करते चले जाएंगे. सो दिस मीन्स द लास्ट पॉइंट which will strike the surface at E, that will be actually this portion, point D on the incident wavefront. We consider here that light is coming in a medium where the speed of light is c. So this means we are talking about a vacuum or air. Okay, so c is the speed of light in the first medium. Now what is this distance dE? This distance dE. So suppose this point D of the incident wavefront approaches this point E in some time t, then the distance dE, this you know from the simple formula is equal to Vt. This will be the speed of light c times t. Okay, so this means this distance dE is just c times t. Now you know according to Huygens, as the incident wavefront hits this reflecting surface at point C will act like the source of secondary waves. इसका मतलब है कि जब तक इंसिडेंट वेव फ्रंट का ये वाला पॉइंट यहाँ से यहाँ तक पहुँचेगा, उतनी ही टाइम में यहाँ से जनरेट होने वाली सेकेंडरी वेव्स यहाँ तक पहुँचेगी. Okay, so according to Huygens, if we consider this point to be a source of secondary waves, what we will do? This will generate its own secondary wave. Suppose this is now some section of that secondary wave generated from the point C. So the CD distance, the CF distance, this is now the radius of that secondary waves produced at the location of C. So what is CF? CF, this is the radius of the secondary wave produced at point C. This will be how much? This radius will be, because the light is reflected in the same medium, so this will be again the speed of light C times T. इसका मतलब क्या है? इंसिडेंट वेव फ्रंट का ये जो डी पॉइंट है, ये जितने टाइम में यहाँ तक पहुँचता है उतनी ही टाइम में यहाँ से जो सेकेंडरी वेव्स जनरेट करेंगी वो यहाँ तक पहुँचेगी, और उस टाइम पर यहाँ से जो सेकेंडरी वेव प्रोड्यूस होगी उसका रेडियस ऑलमोस्ट जीरो होगा. Okay, so this is a small arc over here, this is a big. And now according to Huygens construction, the tangent to these secondary waves will be the final wave front. So let me draw the tangent to these, and this is now my final position of the wave front, which is called the reflected wave front. So FE, this is the reflected wave front. तो अगर ये reflected wave front है तो इसको मतलब कि ये फिर इस डायरेक्शन में मूव करेगा और reflected rays हमेशा इससे perpendicular होंगी. So FM, this will be the reflected ray, and EN, this will be the second reflected ray. Now we want to prove the laws of reflection using Huygens principle. Okay, so we make use of geometry over here, and in this figure you can see two triangles. One triangle is labeled as CDE, this one CDE, and the second triangle is CFE, this triangle. So there are two triangles. Let me draw them over here. One of them look like this, which is labeled as CDE triangle, such that this angle is 90, and the second one look like this. Again, this is, remember, this is point E, and this point is labeled as F, such that this angle is 90. And now, according to our claim, these two triangles, namely triangle CDE, is congruent to triangle CFE. अच्छा, अगर congruent है तो इसका मतलब क्या है कि इनके शेप्स और साइजेस बराबर होंगे, और अगर शेप्स और साइजेस बराबर हैं तो इसका मतलब कि फिर एंगल्स और साइड्स बराबर होंगी. Orientation बेशक different. So you can look into these two triangles and you can see the angle D over here. This is the same as the angle F, because both these are 90 degree. Likewise, the side, the DE side in the first triangle, this one, DE side, which is equal to CT, this is the same as the CF side, this one, which is equal to CT. And CE is equal to CE. You can see this side is common to both the triangles. So this is the common side. तो अगर दो साइड्स बराबर हैं, एक एंगल बराबर है, तो इसका मतलब ये है कि फिर ये कॉन्ग्रुएंट है. और यहाँ से हम ये इस नतीजे पर पहुँचते हैं कि एंगल DCE, एंगल DCE ये वाला एंगल है. सो दिस एंगल इज द सेम एज एंगल FCE. This is not FCE, this is FEC, the angle formed at the vertex E. Okay, this angle. Okay, so this angle in the one triangle is the same as this angle. और अब we say that this angle DCE is equal to theta I. कैसे? तो यहाँ से आप देख सकते हैं. Remember, this is this is the first point where light is hitting the surface. So this is the incident ray. अच्छा, ये आपका इंसिडेंट वेव फ्रंट है, तो ये टोटल एंगल कितना है 90 है. दिस इज एंगल आई, दिस वन, this angle is I or theta I. This total is 90, so this means this remaining will be 90 minus I. And secondly, because this is perpendicular to the interface, so this total angle is 90. Okay, this angle is 90 minus I, so this means this angle is I or theta I. तो अगर ये एंगल थीटा I है, तो अब आप दूसरे ट्राइंगल पर आ जाएं. दूसरे ट्राइंगल में ये जो एंगल है, ये हमारे दावे के मुताबिक थीटा R होगी और ये थीटा I के बराबर होगी. कैसे? So you can look into this figure. Remember, we draw a normal at this point, and the reflected ray is going from this point in this direction. Remember, this side of the triangle, this is the reflected wavefront which is perpendicular to the reflected rays. So this angle is 90, this angle is R or theta R, angle of reflection between the normal and the reflected ray. अच्छा, अगर ये टोटल एंगल 90 का है, ये R है, तो इसको लेके ये रिमेनिंग कितना होगा? That will be 90 minus R, this one. Likewise, this is normal to the interface, so this means this total angle is 90, this one here. अच्छा, अगर ये 90 है, ये वाला 90 minus R है, तो इसको लेके ये जो रिमेनिंग बचेगा, ये वाला inside the triangle, that will be equal to R, theta R. और यहाँ से हम इस नतीजे पर पहुँचे हैं कि ये एंगल थीटा आई थीटा आर के बराबर होगा. ये तो हमें ट्राइंगल्स की कॉन्ग्रुएंसी से पता चलता है. ओके, सो दिस कंप्लीट्स द फर्स्ट पार्ट ऑफ द लॉ ऑफ रिफ्लेक्शन. द सेकंड पार्ट इज the incident ray, the reflected rays, and the normal at the point of incidence must be in the same plane. ओके, सो प्लेन यहाँ पर ये जो पेज आपको नज़र आ रहा है जिसमें मैंने ये रेज ड्रा की हैं, तो दिस पेज इज एक्चुअली दैट प्लेन ऑफ इंसिडेंस. यू कैन से व्हाट इज सी डी in this figure. CD is my incident wavefront. What is FE? Okay, so FE, this is the reflected wavefront. And what is XY? This is the plane of reflection, or you can say this is the interface from which light is reflecting. Now AC, which is the incident ray, this is perpendicular to the incident wavefront CD. EN, which is the reflected ray, this is perpendicular to the reflected wavefront FE. And PC, which is the normal to the interface, this is perpendicular to the interface XY. Okay, so you can see all these three, namely the incident rays, the reflected rays, and the normal at the point of incidence, these are perpendicular to these three things. अच्छा, तो अगर ये इंसिडेंट रे, रिफ्लेक्टेड इंसिडेंट वेव फ्रंट, रिफ्लेक्टेड वेव फ्रंट और इंटरफेस की अगर परपेंडिकुलर होंगी, तो इसका मतलब क्या है? फिर ये तीनों पेज के प्लेन में लाई करेंगी, तो इसका मतलब कि उसमें एग्जिस्ट करेंगी, उसके पैरेलल होंगे. Okay, now we come to the laws of refraction using Huygens principle. And remember, for refraction we need light to be entering from one medium to another medium. So again we draw a horizontal line, and suppose this is now the interface or boundary of two transparent medium. So suppose this portion of the page represents the first medium whose refractive index is n1, where the speed of light is v1, and downstairs here this is a second medium characterized by its refractive index n2, and the speed of light is v2, and we suppose that this second medium is denser as compared to the first medium. तो अगर ये denser है तो इसमें देखिए यहाँ पर फिर speed of light कम होगी बनिस्बत first medium के. So this is now the condition that v1 must be greater than v2. Again, We can draw some lines over here. So these are the incident rays, namely AC is an incident ray which is striking this interface XY at point C, where we draw a normal PQ, and this will be our angle of incidence in the first medium. Likewise BD, this will be the second ray which will eventually reach here and hit the interface at another point E over here. Okay, so according to Huygens, this portion of the wavefront strikes the interface first, and this point will now act like a source of secondary waves. और फिर इसके बाद ये जितने भी पॉइंट्स हैं ये इंसिडेंट वेवफ्रंट पर ये सक्सेसिवली एंड पॉइंट्स पर आके गिरेंगे और आखिर में ये जो पॉइंट डी होगा ये टच करेगा इस पॉइंट ई को। अच्छा, ये जो पोर्शन है इंसिडेंट वेवफ्रंट का डी, ये यहाँ से यहाँ तक कितने टाइम में पहुँचेगा? सपोज इट टेक्स टाइम टी इन रीचिंग फ्रॉम पॉइंट डी टू ई. Okay, so distance DE in the first medium, this will be equal to how much? This will be the speed of light, and remember the speed of light in the first medium is now labeled as v1 times t, अगर टाइम t है। अच्छा, जितने टाइम में ये पॉइंट डी ई तक पहुंचेगा उतनी ही टाइम में यहाँ से कुछ सेकेंडरी वेव्स प्रोड्यूस होंगी। सपोज दिस इज द सेकेंडरी वेव, जस्ट some segment of the secondary wave in the second medium produced by this point C according to Huygens. अच्छा, तो ये जो CF होगा, this will be now the radius of the CF. This will be the radius of the secondary wave produced from the point C, and this will be how much? This radius will be the speed of light in the second medium, which is v2 times t then. तो जितने टाइम में ये पोर्शन यहाँ से यहाँ तक पहुँचे हैं उतनी ही टाइम में जो सेकेंडरी वेव्स इस पॉइंट से प्रोड्यूस होंगी वो यहाँ तक पहुँचेगी। और जाहिर बात है ये दोनों बराबर नहीं है, बिकॉज मीडियम डिफरेंट है तो स्पीड्स डिफरेंट हैं, तो अगर स्पीड डिफरेंट है तो फिर उनके जो डिस्टेंसेस होंगी वो डिफरेंट होंगे। अच्छा, अब इस फिगर की बुनियाद पर हम लॉज ऑफ रिफ्लेक्शन को प्रूव करने जा रहे हैं। Okay, so again we make use of geometry and we see two triangles over here. So one of the triangle is labeled as CDE. Okay, this upper triangle here, CD is a triangle, and the angle, the sine of this angle theta I in this triangle will be how much? Okay, so let me draw this triangle here. Remember this point is C, this is my point D, and this one over here, this is my point E. What is CD? CD is actually the incident wave front. तो लाइट रेज यूं आ रही हैं और ये इंसिडेंट वेव फ्रंट के परपेंडिकुलर हैं। दिस इज द इंसिडेंट रे ओवर हियर। अच्छा, तो ये जो एंगल बनेगा यहाँ पर बिटवीन द नॉर्मल एंड द इंसिडेंट रे, दिस विल बी योर एंगल ऑफ इंसिडेंस। आप उसको थीटा 1 कह ले, थीटा आई कह ले, जो भी कह ले। ओके, सो दिस इज थीटा 1, दिस टोटल एंगल ओवर हेयर दिस इज 90, दिस वन। अच्छा, अगर ये 90 है, ये थीटा 1 है, तो ये जो रिमेनिंग होगा दिस विल बी थीटा 1 90 माइनस थीटा 1। आल्सो दिस एंगल इज आल्सो 90 बिकॉज दिस इज नॉर्मल टू दिस सरफेस, हॉरिजॉन्टल सरफेस, दिस टोटल एंगल इज 90। तो अगर ये 90 है, ये एंगल 90 माइनस थीटा 1 है, तो ये रिमेनिंग कितना बचेगा? दैट विल बी जस्ट थीटा 1। ओके, सो एंड दिस एंगल इज नाउ थीटा 1 इनसाइड दिस ट्रायंगल DCE, and we are finding now the sine of that angle theta 1 or theta I. This will be the perpendicular side, which is DE. Remember, DE is v1 times t divided by the hypotenuse, and hypotenuse is CE. Okay, we call this our equation number 1. Likewise, there is a second triangle CFE in the second medium, this one over here, and in this triangle we are going to find the angle of refraction. So remember, these are the refracted rays in the second medium. जिनको हमने ड्रा किया है, अगर आप यहाँ पर एक सेकेंडरी वेव कंसिडर कर लें, यहाँ पर स्मॉल रेडियस का सेकेंडरी वेव कंसिडर कर लें, so then we draw a common tangent to this will represent the refracted wavefront in the second medium, and the refracted rays must be perpendicular to this refracted wavefront. So Fm stands for the reflected ray in the second medium. Likewise, En stands for the refracted ray in the second medium, and Fe, this is the refracted wavefront which will then follow this path as it moves along. ओके अब इस ट्राइंगल के अंदर ये देख लें, ये आपका रिफ्रैक्टेड रे है, इसका मतलब कि ये जो बाहर का एंगल है ये θ2 होगा, जिसको हम रिफ्रैक्टेड एंगल θ2 या θr कहते हैं। ये जो टोटल एंगल आपको यहाँ पर नज़र आ रहा है, दिस इज़ 90। सो इफ दिस इज टोटल इज़ 90 एंड दिस इज θ2, तो इसका मतलब कि ये जो बाकी बचेगा ट्राइंगल के अंदर, दिस विल बी θ2 90 minus θ2. This angle is 90 because the wavefront is always perpendicular to the rays. So this is 90, this angle is 90 minus θ2. So this means this angle must be then θ2. And now the sine of that angle, this will be the perpendicular side. So remember, this is now the perpendicular. CF is the perpendicular, which is equal to V2 times T from here, divided by the hypotenuse, and hypotenuse is again the same. This is the common side in both the triangles, CE. We call this equation 2. And now what we do next is, for Snell's law, we divide the first equation by the second. So this will be sin θ1 divided by sin θ2, which from here will be just V1t divided by CE divided by V2t divided by CE, and this will end in the ratio of V1 to V2, which if written in terms of the reflective indices of the two media, so V1 will be the speed applied divided by C1 N1 divided by V2, which will be the speed applied C divided by N2. So you know this relation, the speed of light in any medium CV can be written as the speed in vacuum divided by the refractive index N1. So if this is V1 here, this will be N1 here. If this is V2 here, this will be N2 here. And from here we get N2 divided by N1, which is actually Snell's law. Okay, so now we come to the second part of the law of refraction, and that is the incident rays, the refracted rays, and the normal at the point of incidence must all lie in the same plane. Okay, so the plane over here is the page, and what is CD? CD is the incident wavefront. What is FE in this figure? FE is the refracted wavefront. What is XY? This is the interface, which is called the plane of refraction as well. What is AC? AC is the incident ray, which is perpendicular to this incident wavefront CD. What is FM? So FM from here, this is the refracted ray in the second medium, which is perpendicular to this refracted wavefront FE. And likewise PQ, which is the normal to the interface XY, this is perpendicular to it. अच्छा, ये तीनों incident ray, reflected rays और point normal incident at the point of incidence, ये तीनों perpendicular है इन तीनों के, तो इसको मतलब कि फिर ये तीनों लाई करते हैं पेज के प्लेन में. And this completes the second part of the law of refraction.